Hey everyone, today we'll be solving LeetCode problem number 368, largest divisible subset. In this problem, we are given a set of distinct positive integer nums and we have to return the largest subset answer such that every pair answer I, answer j of elements in the subset satisfying these two conditions. Either the answer I is divisible by j or answer j is divisible by answer I. And there can be multiple solutions, we have to return any one of them. Okay, now let's try to understand what the problem statement is saying using this example here. First of all, we will be given a nums of distinct positive integers. It is a set, so having a distinct element. So from this nums, what we have to do is we have to figure out a subset that should be largest, and that subset should be following these conditions that every pair in that subset, every pair is going to satisfy this condition. Let's say the pair is A and B. So either the B is divisible by A or A is divisible by B. So AI AJ, either the AI modulo AJ is equal to 0 or AJ modulo AI is equal to 0. So if this is the case, that subset is a valid and we have to choose the largest subset that is possible. So if I try to get all the subset of 1, 3, it should be 1, 2, or you can say 1, 3, 1, 2, 3. Or if I considering one element also, so it would be 1, 2, 3. And the empty set. Okay, now we have taken all the subsets possible here. There will be 2, 3 as well. So here what we have to do is we have to get the largest subset such that every pair is following this condition. So first of all, let's take the largest one, because if that is our answer, we are going to stop the checking. So 1, 2, 3. Let's say 1, 2, 3. Here the pairs are 1, 2, 2, 3, or 3, 1. So here whether 1, 2 is a valid pair or not. Yeah, 1 can divide 2, because we have to choose any one of these two conditions. Yeah, 1 can divide 2, that is a valid pair. 2 cannot divide 3, it is not a valid pair. 1 can divide 3, yeah, it is also a valid pair. So as all the pairs are not valid, so 1 to 3 is also not valid. So we will not consider 1 to 3. Now comes to the subset of size 2, 1, 3, 1, 2, 2, 3. Here 2, 3 in 2, 3, 3 is not divisible by 2. So it is also not valid. This is also not valid. 1 and 2, we'll check for 1, 2 and 1, 3. Are these two valid? Yeah, definitely, because 1 can divide 2 and 1 can divide 3 as well. So this is our answer. Either you return 1, 2 or either you return 1, 3. One size, one length subset we don't need to check because we have a 2 length answer. So its answer can be 1, 2, or you can say 1, 3. Anyone you can return. This is our problem statement, and these are the constraints given to us. All the integers are unique, and the range is like this. And this question has been asked in Amazon, Microsoft, Adobe, Apple, Bloomberg. So it's a pretty important question. Okay, now let's have a look on this approach. What we did here. Here what we did is captured all the subset to this power n time, and for every subset we check this condition on every pair. If we are getting every pair, that should be n square, and checking this condition is order of 1. So this is going to be the time if we are going with a brute force, but we cannot afford this time. We have to think in a better way. So we had 1, 2, 3 as our nums. First of all, we have to check this condition on every pair, that array of I is divisible by array of j or array of j is divisible by array of I. If we have to reduce this statement to one condition, so in that case it should be the case where age ai is less than aj. That is, the previous element is less than, smaller than the later element. So to make that, what we have to do is we will be sorting our nums. So if we are sorting our nums in this way, now we have to find the subset of largest length, where array of I let's say I is a bigger loop, array of j equal to 0. J is a smaller loop inside I. Now like how do we do this? So here we will be thinking in terms of dynamic programming, considering the smaller example first. So 1, let's say if the nums is having this element, one element, do we have to do anything? Yeah, no. 1 will be our subset and 1 will be our answer in this case. So if it is having two elements only, 1 and 2, so for 1 we already know the answer, that this 1 is the answer. This answer is specifying that the biggest subset we can get, that is ending with 1. So for 2, what we need is we have to see what is the biggest subset that is ending with 2. If it is ending with 2, so we will be checking what are all the elements before 2 that are dividing 2. Before 2 there is one element which is 1. 1 is dividing 2. It means the elements, the subset ending at 1 will also be the part of that subset. Because if 1 is dividing 2, it means all the elements in this subset are dividing 1. And all the elements in this subset are dividing 1 and 1 is dividing 2. It means all the subset in this answer is dividing 2. So we can take this subset and put it here and add 2 as well. So 1 and 2 will be the answer. Or if I take, we have given 1, 2, 3. We know the answer of 1. Largest subset ending at 1 is 1 and largest subset ending at 2 is, checking from left to right, what are all the elements dividing 2? 1 is dividing 2. So we are picking this subset and putting it here and after that adding 2. So this is the subset where every pair is satisfying our condition. 1 is dividing by 2. Yeah, satisfying condition. Now let's come to 3. Here what we have to do is we have to see for the for all the elements which are dividing 3. So from left to right we will check for all the elements whether 1 is dividing 3. If 1 is dividing 3, all the pairs, all the items in this subset is dividing 3. So we can pick the subset, putting it here and then adding 3 as well. This subset is going to satisfy our condition. Now we have all the answers or all the subsets, valid subset ending at ith index, and we can, among these we can capture the maximum subset. So the maximum subsets are these two, so return any of these. I hope this approach is clear to you. This is a dynamic programming approach. This is the same logic we are using to find longest increase in subsequence, that we have to find the longest increase in subsequence ending at 1, then longest increase in subsequence ending at 2. The same kind of logic is applying here. So let's work on a bigger example so that will be more clear to us. Let's say we have this 2 3 4 9 8, 2 3 4 9 8. This is our array and let's say I is equal to 0 in the starting. So for I equal to 0, first of all we will see what are all the subsets before I. There is no subset, the empty subset is there. It means 2 is the only element that will be added to that subset, because in this 2 subset every two elements are dividing each other. It is having one element only, so that means it's already following, satisfying the condition. Now we know the answer ending at 2, answer all the subsets and ending at 2. Now we have to see what are all the subsets that can be our answer and ending at 3. For that we have to look on the smaller problem first. These are the smaller problems and we will see whether there is any element which is dividing 3 or not. No, none of the element is dividing 3. And before that, make sure that this array is sorted, because we are building our algorithm as per the condition that this array is sorted. So if it is not sorted, do the sorting. Arrays dot sort nums, sorting in the increasing order. So once it is sorted in the increasing order, it will be like this: 2 3 4 8 9. This is our first step. This is our second step. We are using two loops, two nested loops, one for I and one for j. Okay, now let's come to the point here. We need which is answer with subsets ending at 3. So Before 3, no element is dividing 3. It means there is no valid subset or pre-existing. In the 3, it will be the only element. It means for 2 and 3, the valid answer is 3. Now what we'll do is we'll check for our candidate subset which is ending at 4. So we will again try from left to right and we'll see what are the element dividing 4. 2 is dividing 4, right? It means all the elements in this subset will be dividing 4. So we can directly take this subset and then edit 4 as well. So 2 and 4 will be the two elements ending at 4. So if our array was 2, 3, 4, our biggest answer, biggest possible subset could be 2 and 4. Now we comes to 8. We will check for the elements from left to right again which are dividing 8. So 2 is dividing 8, right? It means all the elements in this subset will be taken to here. So if we take here and then add 8, yeah, right. Now we see that at 4 the elements are, we will just take 2 for now. Now at 4 the elements are 2 and previously we have captured the elements 1. It means 2 are bigger than 1. So we will be considering this subset, discarding this one. So we consider this subset. So from all of these smaller elements, we consider 2 and 4. It means 2 and 4 are the elements which will be dividing 8. So if I add 8 here, if I add 8 here, it will become 2, 4, 8. That is, this is the subset that is that can be our candidate, and we can return the subset from the problem. Now we check for all the elements, all the subset ending at 9. Ending at 9, we will see what are all the elements which are dividing 9. So 3 is our only element dividing 9. It means we can have only this as a valid option, 3. After that we can add 9. So ultimately it will be 3, 9. Nothing else. So now we have captured all the subsets ending at a specific position. And here if we see that this is the largest one. So we can directly return this one. Here in the LIS, we were just storing the length of the largest increase in subsequence, the basic LIS problem. Here what I can do is, this is a list. This is a list, and in every list I am storing a list. So the data structure here used, what we can use is list of list. You can call it anything, or you can call it DP as well. So here in this list, whatever list is having the longest list, that is our answer. So 2, 4, 8 is specifying is following our condition. Here 2, 4 is a valid pair, 4, 8 is a valid pair, and 2, 8 is also a valid pair. So we will return 2, 4, 8 from here. Okay, now let's try to code this problem. And what is the time and space complexity of this approach? So time for this approach is that we are maintaining this list 2, 3, 4, 8, 9, and for every index I'm iterating all the smaller index. So it will become order of n square. And what is the space complexity? Space is also going to be the same. At every position we are storing a list, and that list can go up to n size. So it will be of order of n square. So it's way better than the previous approach, in which we were extracting all the subsets. Now let's try to code this out. First of all, we have to sort our nums array. Arrays dot sort nums. Let's capture the length of this nums dot length. Now we'll be iterating over this nums array. Before that, let's take our dp array, list of integer. dp is equal to new array list. Okay, that is fine. We also have to initialize this list for I equal to 0, I less than n, I plus plus. The same number of list I will be adding the same as the number of element in the nums array. So dp dot add new array list. Okay, now dp array is prepared. I will be iterating over our main loop. I equal to 0, I less than n, I plus plus. For every ith element, I will be checking all the smaller element to it. So for that, int j equal to 0, j less than I, and j plus plus. So for every smaller element, I will capture the subset we have captured so far, maximum subset we have captured so far. So to capture the maximum subset, I will take another list, integer dot integer, list of integer, maximum subset equal to new array list. Okay, so if there is no subset in it, in that case, it will be considered as an empty subset. So now for every j equal to 0 to j less than I, we will see if nums of I divided by nums of j is equal to 0. And the other thing is that our maximum subset is having a size smaller than the current subset. Maximum subset dot size is less than the dp dot get j dot size. If that is the case, we have a new candidate which of bigger size. If we get a new candidate, we'll be updating our maximum subset. Maximum subset equal to dp dot get j. Okay, got it. Now here using this loop we have captured our subset so far, and now what we'll be doing is, let me tell you, like using an example. Let's say for 1 2 3 we are at 2, and we our maximum subset capture so far is 1. So first of all we will be adding 1 and then we will be adding 2 to a new subset. So maximum, not the maximum subset, dp or dot get I, right? So first of all add all from maximum subset, dp dot get I. Now add nums of I. Okay, now all the elements are captured, and here our main logic is done. Now what we have to do, if you keep on doing this, ultimately you have to make one more iteration to capture the maximum subset. So instead of doing one more iteration, just capture here along with the loop, because we have captured dp of I only once and we are not changing that. So we will see. For that we can take two variables, int answer dot length, answer length. Let's say it is 0, and answer index, let's say it is -1. You can initialize with it with any values, any smaller values. So if answer dot length is less than dp dot get I dot size, so we have found a bigger subset. It means we are going to capture that. So answered length is equal to dp dot get I dot size, and answer index is equal to I. So ultimately this answer index is going to store the index of largest subarray. So for that I'm going to return answer idx, sorry, dp dot get answer idx. Okay, now our coding is done. Try to submit over sample test cases. Okay, it is working fine. I'm submitting the problem. It's submitted successfully. Hope you understood the problem. Thank you guys. If you have any doubt, you can comment down below.